Good morning everybody, and thank you very much for the invitation to come and speak here. I think this is such a wonderful and important topic. It is great to see so many people from so many different countries, so many different fields of study, and what I'm going to talk about today is the importance of every discipline, every area that people study can be brought together and combined to talk to each other, to work together and produce good sustainable development. I'll talk about my area. My field is information systems. I'll explain what that is. It's not just IT. So I'll talk about that, and I'll talk about some of the things that we are in the discipline of information systems doing. But what I would really like is for you to see how what you do would work with what I do and what each other does to promote the whole area of sustainable development. So I thought we would start with the big picture. The conference is about sustainable development. And in my discipline, we do have a lot of discussion about what the word sustainable means and whether we should use the word sustainable. To me, the word sustainable has a connotation of conservatism, of keeping things the way they are, of not wanting to move into the future. But sustainable development has a completely different idea. The idea that we are going to change, that we're going to develop, that we are going to do things that will take us forward, and we will do it in a way that we all contribute to and all get benefit from. So I'm going to start with the motivation of why we should do this, and I have two very important motivations. I'll go on to the... Okay, this is the motivation for what I do. On the left you see my three daughters. They are all now grown up and have children of their own. On the right you see my grandchildren. I have 5 of those. And I was just thinking as I fly over here, it's a long way from where I come from Australia, of the, what it'll be like when these grandchildren are my age. They will be worried about their grandchildren. So we have a lot of targets about sustainability, sea level rises, temperature rises. We always look several decades into the future for those. But we are all concerned about those decades. We are not just concerned about what happens tomorrow. So I'm looking to 60 years' time when these grandchildren are my age, and they will be worried about their grandchildren in 60 years' time. So we can think about these long-term adventures. And as the Minister just says, that we're meeting the needs of the present without compromising the ability of all these future generations to meet their own needs. I have another reason though. I think you all recognise the planets. That lovely blue one and the top in the middle is us, and we created a wonderful environment in which life could exist. I started off in my career as a physicist, and I was going to go into astronomy as my major until computers came around and I got excited about those. But when you look around the other planets, wherever we go nearby, we have no evidence that life even exists on those, let alone intelligent life like us. So we have nowhere really close by to go if we stuff up this planet. So that's something that's really important. Okay, so what can we do? We really need to do something. I hope I've convinced you on that. And one of the catchphrases that we use is to think globally and act locally. So we all know that sustainable development is a very complex global issue. We're here to recognise it, to discuss it, and to look at ways in which we can do something about it. But we also need to act locally. And I'm going to propose that we have two locals, if you like. One is geographic, and the other is our disciplines. So we need to understand our own locality, but we also need to understand our own disciplines, what we know, what we as professionals understand, how we can contribute with others to do that. Now, my field is information systems, so my local discipline, if you like, is Green IS, and I'll talk about that later on. Just going back to geography for a minute. This is where I live. It's a beautiful place. I've been talking to some people this morning who've been to Wollongong. It's on the coast just south of Sydney in Australia. And I took this picture when I was down at the beach one afternoon, and it just looked beautiful. So it's a lovely place. This is Australia. It's one of the most recognised countries because it is a complete island and it's big, and you see it on the map. If you can see from there, the centre is all brown. There's just some little green bits around the edge. So we all live around the edge, and that's where life really is only sustainable in Australia. There's no water inland. If the sea level rises, we are going to have problems, and we're planning for that. This shows you the roads and basically all the main roads around the side. That's where people live. It's a very interesting place, very different from probably what most of you experience. Last time I was in Europe, I had to do a talk in Germany, so I did a comparison of Australia and Germany. So I tried to get some information about Bosnia as well. If you look at the area, we're huge, 7,686 square kilometres, 7 billion square kilometres. We're the sixth largest country in the world. Germany is much smaller by comparison, and here is even much smaller by comparison. We have a huge coastline, nearly 36,000 kilometres of coastline. Germany has 900, and you have about 20, which is not very much. You are not very exposed to sea level rises. We have a population of only about 23 million. Germany has 90 million, you have 4 million. Three very different countries as far as population. We have this huge country, very sparsely populated. Our GDP, though, is very good in comparison. We're in a developed country. Our emissions are very high. Our greenhouse gas, GHG emissions, are very high, and very high per capita. Not very much if you take the whole country and look at the amount per square kilometre, because we're a big country and low population. So we have different challenges, I think, to other countries. Each country has its own challenges. We're always criticised because we have very high emissions. One of our major products is brown coal, and that's not very good as far as polluting the atmosphere is concerned. So we have some concerns. Just quickly, I'll show you some of the things that do happen in Australia that makes us aware of climate change and makes us think we need to do something about this. The top pictures are from my hometown. We have floods there, very big flood in 1998. The water came up to my back door, and many of the houses around us were flooded and washed away. We had very severe floods in Queensland in 2011, and an area greater than the combined size of Germany and France were flooded. It was huge. It was a very big disaster that we had to cope with. And the problem was not just one thing, but the problem with all of the challenges we're now getting from climate change are that many things happen together. So that we had lots of rain, high floods, high tides, and the two combined with a big storm produced huge floods in populated areas in Queensland. We have fires. We had some devastating bushfires that destroy huge tracts of land and people. I've put the right-hand map in there. If you can see that red line, that's where the edge of the very flammable bush that we have in Australia is. And I live just near there, so we're very concerned of what would happen when things are very dry and we don't get much rain, we get these devastating bushfires. You see a lot in California as well, the same sort of bushfires. We have drought. We had a long drought that we're just recovering from now, and those floods were when the drought broke and we suddenly go from one extreme to the other. And we get storms. That red thing there is a cricket ball. Anyone know cricket? Some of you would know cricket. But it's the size of a tennis ball. We get hail that size in Sydney, and it does a lot of damage. Okay, so we're very conscious of changes in the climate. It affects us very greatly. Okay, so now let's go back to my discipline. I cross over two disciplines, if you like, which are very closely related. IS stands for Information Systems, and KM is Knowledge Management. Knowledge management is a bit more recent than information systems. So I'm sure you've all heard of IT. Well, information systems is, I'll go through some of the words up there, it's design, development, implementation, use and impact of information systems. And these systems are not just IT, but social systems. All the systems that you have at work to manage your payroll, to manage your customers, they have a technical component, but also there are social components that interact with them. You have procedures that you must follow. You have to be trained. And all these systems affect what you do. It's very easy when things go wrong to blame the computer system. It's very frustrating when the computer systems don't work. So information systems is a very comprehensive discipline that looks at not just technology, but how you design it, develop it, use it, the impact that it has on you. So it's quite a broad discipline. Knowledge management is a discipline that grew out of information systems when people started to realise that it wasn't just information that was useful. To be able to do something, you need knowledge. And knowledge is supplying individuals and people with the tools and other IT and other tools so they can learn and grow and apply what the information tells them in a useful way. So they're what I study. It's quite a broad thing to study. Just emphasising the fact that information systems goes from looking at the IT resources, IT services, to the definition that I like, the second one there, which came from the editor of one of our major journals, Alan editors MIS Quarterly, which is the top journal in information systems. And he says, research in information systems examines more than just the technological system or just the social system, or even the two side by side. In addition, it investigates the phenomena that emerges when the two interact. So when people and technology get together, that's when you get the sort of thing that I, as an IS person, studies. Okay, so just a bit of history of my whole field, before I start telling you about Green IS. In the 1960s, we started to get systems in organisations, in banks, in insurance companies. They started to replace all the manual calculations that they used to do with computers. In the 1970s, we got much better at developing these. We had what are called third-generation programming languages, which made it so much easier for people to develop new and more diverse systems. I don't know how many of you go back this far, some of you probably don't. The 1980s was when the personal computer first emerged. They were very primitive at first, but nowadays we wouldn't do without them. In the 1990s, though, are when things really started to take off in my area. And I can remember back in the 1990s reading about this area called knowledge management. It wasn't just information, but we wanted knowledge. We could learn and do things with computers. We had them at our fingertips. We didn't have to deal with a technician to do something with the computer. You could do it yourself. And these networks emerged, email, the internet, all the things we now take for granted. It's only in the 1990s that these things started to happen. So we went from information to knowledge to really using tools to make much better sense of the world, sense-making. Then in the last decade, we've gone from what's called Web 1.0, which is the internet with websites on it, to Web 2.0, which is very much more interactive. And there are lots of applications that now sit on the internet that we can use. We can create our own videos on YouTube. We can put slideshows up. We can put PowerPoints up. We can talk to each other. I regularly Skype to colleagues in New York. And the technology's fine. The technology works. We can talk. We can see each other. We can share documents. The one thing that's a problem is time zones. The only time zone that we can overlap is when it's early morning my time and evening over in New York. So we're constrained by some things. And now we have this thing called the cloud, where a lot of applications don't have to reside on our own little desktop, but if we're connected to the internet, we can do almost anything. Okay, so we've got the internet. The internet is what I call the world's biggest information system. And one of the former CEO of Google said this about the internet. The internet is the first thing that humanity has built that humanity doesn't understand. It's the largest experiment in anarchy that we have ever had. I think everybody has some view of what the internet has meant for their life. And if you don't remember what life was like before the internet, talk to someone who does. So we've developed this crazy interconnected artefact, and we continue to develop it, it continues to grow, and it influences everything we do. Just going to make a distinction between the internet and the web. The internet is the interconnection of computers and its networks of physical computers. On top of that, we have the World Wide Web, which is websites and applications and all the other things that we interact with. Okay, so the history of that goes back also about the same time. In the 1990s, some military scientists set up ARPANET, which was a very primitive system for them to exchange information and data. And then we had these things called email. And is anyone here remember Telnet and FTP? They were protocols on top of the old internet to enable us to do some things. The first issue of the main journal in information systems came out in 1977. So it goes back a while. And then in the 1980s we have personal computers, and 1990 the web, and we have HTML, HTTP, URL. Everyone's familiar with those devices. They were very interesting concepts. We take them for granted now. We all learn about them, we know about them, we use them all the time. We see web pages and the tag text inside the HTML. We have HTTP is the way that your computer can be recognised on the internet and with its URL. Those things were invented in the 1990s. And the one thing that has really made a difference is they were given away free. The people who invented them didn't insist on copyright or any sort of recompense. Tim Berners-Lee, who was the main driver of all this, said it's all going to be open and free. We're going to give it to everyone. And so we've had this huge explosion of the internet. Okay, so very rapidly we've had this increase that years go along the bottom, and 1990s is where, mid-1990s, 95, 96, 97, is where that curve just starts to take off. That actually shows the number of world internet hosts, but it could be anything to do with the internet. It has this rapid takeoff. So, what has resulted? We've had this huge increase in complexity. The environment is very much more connected. We're all interconnected in all sorts of interesting ways. We can email, we can work 24 hours a day, 7 days a week. And the ICT, the internet and the web have been responsible for a lot of that, and it's all happened very rapidly. So one of the ways in which I do research in this area is to use complexity theory. Now there are various versions of complexity theory, but it's about the way that systems behave over time and space. And I'm going to talk a little bit more about how we deal with complex adaptive systems. There's no unified view of complexity, but if you can read the green bit down the bottom, it says, the key findings claimed for complexity theory is the effective unknowability of the future. So if the world is complex and virtually we cannot know what's going to happen in the future, how can we plan? How can we do this sustainable development? Because we really don't know what's going to happen in 5 or 10 years' time. 5 years ago, there was no Twitter and Facebook, and yet they're part of our lives. Who knows what on earth's going to be here in the future? So I talk about complex adaptive systems, which is a large number of elements that there's too many of them and too many of them interacting to be able to do anything practical as far as analyse them in the way you would like to scientifically. I can see in front of me a lot of students. You are often being told to find variables, to see how independent variables affect some outcome with dependent variables. With a complex system, you can't do that. You can't say, these are the variables, these are what their values are, this is what their values will be, and this is how they will affect other variables. There's too many variables in a complex system, and that's what we've got now that we have to deal with to make the world sustainably develop. So we can't use it. We've got to allow a thing called emergence, which is a common word in complexity theory. We've got to allow self-organisation and non-linearity. Now, this is not the way that people like to run countries or big corporations. They want things controlled. They want things ordered. They want to know what's going on. They are not going to allow things to just emerge. They are not going to allow their workers to self-organise. And so you've got this very big tension between the old way in which organisations used to work, top down, manager at the top, people down the bottom doing the work, everything ordered. These days we've got many more organic type ways of organising networks of people working together. The other thing about complex adaptive systems, have you all heard of the butterfly effect? If a butterfly flaps its wings on one side of the Pacific Ocean, which is very big, it could cause a cyclone or a tornado on the other side. Small differences in the initial starting conditions of anything can have big effects on the outcomes. So you can't tell, and you never know all these little starting conditions, so you can never tell what's going to happen. Okay, so we don't have any cause and effect anymore. We can only see it in retrospect. We can only know what caused what after it's happened. That's a bit disconcerting. So you can't really state a hypothesis to prove, as many of you students will be doing for your theses, I presume. Everything's very context dependent. So even small differences in where you're doing an experiment or where you're doing some study can mean the outcomes can be very different. So you can't generalise your findings. You can learn a bit from a single case study, but you've got to approach the whole process of research differently if you're looking at very complex adaptive systems. Okay, so information systems, my discipline. In the 1990s, it was described as a federated adhocracy. That means a whole lot of different people with different ideas coming together in a rather non-structured way. We have many topics and themes. We're multidisciplinary, cross-disciplinary. We do take a systemic approach to things. We look at things as systems, but we say that a system is much more than just the sum of its parts. A system is there for a purpose. We create and study them, but the problem with a complex world is all these different systems interact. The Minister was saying earlier about the social, the economic and the environmental. Those three systems all interact with each other. Most politicians, and I presume we have some here, like to talk about the economy